Now, after theorem 10.1, let us move to theorem 10.2, which states that the length of tangent drawn from an external point to a circle are equal. Means from any point which is outside the circle, we draw the tangents. Okay, from any point we draw the tangents, then their length will be equal. The tangents drawn from any external point are equal in length. Okay. See, here we have a circle with center O. P is the point which is external, means outside the circle. From this external point P, we have drawn two tangents which is PQ and PR. So, the length of tangents PQ and PR which is drawn from the same point P will be equal. We have to prove that length of PQ and PR is equal. Okay, now we will join point O, which is center of the circle, to this point of contact Q, and O to R, which are also radii of the circle, and we will join center of the circle with this external point P to get line segment PO. See what is given to us, what already we have for this to prove this theorem. Two tangents PQ and PR are drawn from point P to the circle with center O. That is, OQ and OR are the radii, which I already said. Okay, and they will be equal. What we have to prove? We have to prove that PQ is equals to PR. PQ is equals to PR. Now, what construction we will make to prove this? Already I said join O to Q, O to R, and OP. OQ and OR are radii, and OP is the line segment joining center to the external point P. Okay, now come to the proof. See, we have two triangles. After we join P and O, we will get two triangles. First triangle is OQP and second triangle is ORP. We will get two triangles. Okay, and if we prove these two triangles congruent, then by CPCT, corresponding parts of congruent triangle, we will get PQ is equals to PR. Okay, so see, in these two triangles, we have angle OQP equals to angle ORP, which is both 90 and 90. These both angles are 90 because we know that from theorem 10.1, tangent drawn to a circle is perpendicular to the radius through point of contact. So OQ is perpendicular to PQ and OR is perpendicular to PR through point of contact Q and R. So these two angles are 90 and 90. Okay, now next PO. PO is common in both the triangles, which is also hypotenuse of these two right angle triangle. PO is hypotenuse of this triangle also, and PO is hypotenuse of this triangle also. So PO is equals to PO. This line segment is common, and OR is equals to OQ. OQ is equals to OR. Why? Because they are radii of the same circle. Okay, which is also another side of both the triangles. So by right angle hypotenuse side, two triangles, triangle OQP and ORP are congruent. Okay, now if two triangles are congruent, then their corresponding parts are equal. Okay, so PQ and PR are the corresponding parts of these two congruent triangles. So they will be equal by CPCT. Okay, also see, triangle POQ and triangle POR are congruent, means all the corresponding parts will be equal. See, if angle OPR is getting divided by line PO. Okay, yes, clearly we can see that angle OPR is QPR is getting divided by line segment PO, and if these two triangles are congruent, then by CPCT this angle will be equals to this angle. It means what? This PO is the bisector of angle drawn at the external point, which is P. Here x will be equals to y. This angle x is equals to angle y. Similarly, this line segment PO will be bisector of the angle drawn at the circle with these two different radius. Means angle angle QOR is also getting bisected by line segment PO, means angle A is equals to angle B. Okay, see. Also, if a tangent is drawn from external point to the circle, the line segment joining the external point to the circle to the center of a circle is angle bisector of both the angles, angle P, angle QPR and angle QOR. Okay, the line segment joining the external point and center of the circle will be the bisector of these both angles. Okay. That means PO bisects angle QPR as well as angle OQR, whereas X is equals to Y and A is equals to B. This angle is equals to this angle, X equals to Y and angle A is equals to angle B, as PO is bisector of both the angles. Okay, see. Now in this video, we are going to solve question number 3 of exercise 10.1 using theorem 10.1 itself. See what the question is. A tangent PQ at a point of a circle of radius 5 cm meets a line through the center O at a point Q, so that OQ is equals to 12 cm. Find the length of PQ. Question is saying that a tangent at a point of a circle of radius 5 cm meets a line. Tangent is meeting a line which is drawn from the center of a circle. Okay, and the point of meeting is, point of intersection is Q, such that OQ is 12 cm. Okay, and radius OP is 5 cm. We have to find the length of tangent PQ. Okay, see, radius of the circle with center O is OP, which is 5 cm. OP, P is the point of contact of radius and tangent, and OQ is 12 cm. We have to find the length of tangent PQ. We know that from theorem 10.1, we know that tangent drawn to a circle is perpendicular to the radius through point of contact or at point of contact. So QP is perpendicular to OP, or OP is perpendicular to QP. By theorem 10.1, as tangent at any point of a circle is perpendicular to the radius through point of contact. So clearly we can see that in triangle OPQ, angle OPQ is 90 degree by theorem 10.1. Now we can apply Pythagoras theorem to this triangle. Pythagoras theorem states hypotenuse square or square of the longest side is equals to sum of square of other two sides. So OQ square is equals to OP square plus QP square. Okay, so OQ is 12, OP is 5 and QP is or doesn't given, it is not given. So OQ is given to us, which is 12, OP is also given to us, which is 5. QP is not given. QP we have to find, which is PQ. QP or PQ, both is same. Okay, both are same. Now 12 square is equals to 5 square plus QP square, which implies that PQ, if we transpose this 5 square to LHS, it will become 12 square is 144, 5 square is 125. So 144 minus 125. So PQ square is equals to 119, and it is PQ square. No, so we need to transpose this square to RHS so that it becomes root over 144 minus 25, which is root over 119 centimeter. So length of PQ is 119 centimeter. Okay.